Hello and welcome to this video on the set reset latch. The set reset latch functions like the toggle switch. It can be toggled between outputting high on Q or inverse Q. This circuit has memory because it uses sequential logic. Sequential logic circuits internally feed some or all of their outputs back in as inputs. The output is affected by both the previous outputs and the current inputs. The SR latch can be used to store one bit of memory or switch between two modes. The SR latch has the following behavior. Starting in the unset state, where Q outputs low and inverse Q outputs high. When input set becomes high, Q output is switched on and inverse Q output is switched off. Even though set input has now returned to low, the state of Q and inverse Q is unchanged. When reset input becomes high, Q output is switched off and inverse Q output is switched on. Even though the input reset has returned to low, the outputs are unchanged. So how does the SR latch work internally? Well, there's different ways to make an SR latch circuit. One way is to use two NOR gates as shown, having the inputs R and S being fed into one of the NOR gates and having the output of each NOR gate fed into the other NOR gate. Quick reminder, a NOR gate is true only when both inputs to it are false. Once the set input becomes high, the bottom NOR gate will no longer have two false inputs, so it will output false. This will switch inverse Q off, and it will be fed back into the top NOR gate. The top NOR gate will now have two false inputs, and therefore return true. This will cause Q to be switched on, and it will feed back into the bottom NOR gate. When the set signal returns to low, the gate remains latched with Q on and inverse Q off. So now let's reset the latch. When the reset signal becomes high, the top NOR gate no longer has two false inputs, so it returns false. This switches the Q output to off, and it feeds back into the bottom NOR gate. The bottom NOR gate now has two false inputs, so it returns true, and it feeds back into the top NOR gate, and inverse Q is switched on. When the reset input returns to low, the latch remains latched in the reset setting. Note the SR latch shown in the example is an SR latch that responds to a high input, also known as active high SR latch. There's also an active low SR latch, which treats a low input as the trigger input. You may be wondering, what happens to an SR latch when set and reset are active at the same time? Well, this is generally considered to be an invalid input. It usually results in erroneous outputs, such as both high or both low. Some SR latches respond to this input in one of the following ways. They treat it as a set signal, set dominant SRs. They treat it as a reset signal, reset dominant SRs. Or they ignore it completely and maintain their current state, hold dominant SRs. Some SR latches have a third input called enable. Such latches will not change their state unless the enable input is currently active. In order to set a gated SR latch, you must have set and enable active. In order to reset it, enable and reset must be active. Otherwise, it will just hold its current state.